Hey everyone, in this video we're going to look at horizontal stretch and compression. So we already took a look at vertical stretch and compression, so let's see what this is about. So again, we'll start with three functions. Let's start with our base function. This time we're going to switch our base function to x cubed. Then let's take g of x is going to be 2x quantity cubed, and then h of x is going to be 1/2 x quantity cubed. Okay, so let's go ahead and make a table as we always do. We have x, then we have x cubed, we have 2x cubed, and then we have 1/2 x cubed. Okay, so we have, say, our regular points, -2, -1, 0, 1, and 2. If I take cubes, -2 cubed is -8. This is -1, 0, 1, and 8. 2x cubed, well, if I put in 2 here, I get -4, and -4 cubed is -64. Then -1, if I multiply that by 2, I get -2 cubed, which is -8, 0, 8, and 64. 1/2, if I multiply that by -2, I get -1, so this is -1. This is going to be -1/2 cubed, which is -0.125, 0.125, and 1. Right? So let's go ahead and graph these points and see what we get. So we see here the graph of our base function, that is x cubed, and as you see, this graph is also symmetric about the origin, right? Now let's go ahead and see what happens when I take the graph of gx, which was 2x cubed. So here are the points for 2x cubed. Let me go ahead and zoom out a bit here. What do we notice? We notice that these points seem to be closer, right? They seem to be closer to the y-axis, okay? So it seems like they're being compressed towards the y-axis, all right? So let's go ahead and get our function, and it does look a little more linear actually, so it looks like it is more compressed, right, from both sides. And then let's look at our graph of y equals 1/2 x quantity cubed, and if you see here, well, we see that these points seem to be a bit more spread out, so it looks like they're being pulled away from the y-axis, right? They're moving away from the y-axis. And again, if I go ahead and grade this, we see that this function is way more stretched than your function f of x, right? So what happens when we multiply that number within that parentheses in there, right? What do we get? So let's see. So here's a function bx cubed. So right now you can see here that b is equal to 1, and so obviously it's x cubed, and that's our base function. What happens when I make b to be greater than 1? So as I make it greater than 1, you guys see here that it looks like now this function is being compressed, right? It's being compressed towards the y-axis, right, from both sides. So it's getting closer and closer to the y-axis. And again, if I come to 1, we'll be back at our base function. Now as I decrease the value from 1, between 1 and 0, as I pick values between 1 and 0, notice how the function is now, right, it's being stretched. You can see that this function is actually being stretched away from the x-axis, from the y-axis, right? So we see that the smaller the value, the smaller the positive value, right? So 0.48, 0.4, you see that there is more stretching that is taking this function away from the y-axis. Okay, so consider the graph of y equals, or actually, I'm going to start this again. Okay, consider the graph of gx equals f of ax, or f of bx, okay, where b is some constant. Now, if 0 less than b less than 1, right? We saw here that as you make that b smaller, what happens is your function is actually getting stretched, right? So the graph of gx is the graph of fx stretched horizontally away from the y-axis. Okay? And then we also saw that if b is going to be greater than 1, then the graph of gx is the graph of fx compressed horizontally toward the y-axis.